And while giving variable names, try to avoid the keywords that are already defined in the C++ library. They have some different meanings. Uh, the data types, obviously, int, double, float, they have a specific meaning in the C++ grammar. So do not use them as your variable names. Also, there are certain keywords like for, class, return. You do not know these keywords yet, but if you just write a keyword, it will get a different color. See, this white color, this is a keyword. This data types always get this deep blue color. I'm talking about Visual Studio. And if you write a word which is not defined in the C++ library, then this will be the light blue color. Okay, this is easier for you to identify if there is a keyword like that or not. And the best way to avoid any such clashes, if you are not sure if total is a keyword or not, just add some numbers with it, like 1, 2, or total calculated. You will never have a keyword like this. So make your variable name such that it makes some sense to you and makes your code readable, as well as it does not clash with a keyword. So you can have variable names like this, and these are some good and bad examples of variable names. Some good examples are these. Here, you can look at these variable names, and right away you can tell me what each of these variables are holding or in the program. So student age, this variable must be storing age of some student. This variable radius must be storing some radius. And this total marks must be storing some total of some marks. So your variable names should be self-documenting. Just looking at the name of your variable, you should be able to tell what that variable is storing. And these are some bad examples because you just by looking at the name of the variable, you cannot tell what kind of data is stored in that variable. Okay. And there are different ways to read data into your variable. We saw the first way, which is hard coding values into your variable. There is another way, which is reading from the user. Suppose I have a variable like this, and I initialize it with 0. This is called initialization, giving some initial value to it. That doesn't necessarily mean that it is the value that you want to assign to the variable. It is just a placeholder. Now, later on, you want to read the value of that variable from the user. So this is how you can read user input. Obviously, I will go over this again in my future lectures. So for that, you will have to prompt the user with some message, like enter some value, enter a number. So this will be printed. So when you will run the program, you are the user, right? In this case, you are the programmer as well as you are the user. Someone who will be using your program, they will not look at the code. They will just run your code and will use the application that you are building. The different applications that we use, we do not look at the code of those applications, right? So you will have to give messages to the user so that the user knows what to do. Here, you will just print a message for the user, enter a number. And now you can read the number from the user like this. With the tool called cin, you already saw how we can use cout for printing something, and cin is for reading some value into a variable. This is the variable that we created, and using cin, we can store values into the variable. So when the program will run, this cin will read some value from the user, and that value will be stored into this variable called total calculated. This operator, this insertion operator, will insert, I think this is called the extraction operator. This was insertion operator. This is the extraction operator. This extraction operator will extract the value that the user will provide, and it will store that value into this variable total calculated. And now if I try to print this, it will give me the value that the user will provide. Let's see if that is happening or not. So this is the terminal that you will see. Here it is prompting me to enter a number. It is printing that. So let me give some number. I will give 8 here, and I will have to press enter. So it is printing that you entered 8. That's the value which is stored into the variable called total calculated. So this is one way of reading values into the variable. We can directly write the values in your program that you already saw, which is called hard coding. You can read values from the user, and also you can get values from a file that you have in your machine. We will go over those things later on when we will learn about files. Now let's talk about constants in C++. Constants are very similar to variables. You already saw how we declared variables. In the similar way, we can declare constants. Just that we have to add one more keyword together with the variable declaration to make it a constant, and that keyword is called const. That is short form of constant. Why do we need a constant? You saw whenever we are using a variable, we can change the value of the variable anywhere in our program. So the user will give some value here, and I can change that value like this. Okay, you do not yet know what is plus equal to, so I will just write it like this. Total calculated plus 10. If I just write this, that means I'm adding some value to the variable total calculated. And that is accepted by the C++ compiler. And now if I print this, let me run this code. Let me give 20, and it is printing 30 because it is adding 10 to it. So this is how you can reuse the variable that you saw. You are reusing the variable in your program, and you can change the value of the variable anywhere in your program. That is allowed. But if you declare it as const, suppose I add this keyword called const in the beginning, then what will happen? First of all, I will not be able to read some value into this constant. That is not allowed. Let me see what the error I will get. Let me run this and see if I'm getting a better error message. It is telling me the expression must be a modifiable value. That means this is not modifiable. Since I have declared it as constant, I cannot modify this value. Okay, so that's the only difference between constants and variables. Variables, you can change the value anywhere in your program. But for constants, once you create a constant and assign some value to it, you will have to maintain that everywhere in your program. Here also, I'm trying to change the value of that constant, and it is not allowing me to do that. So I will just remove this line. I will have to maintain the value of total calculated as 10 everywhere in my program. Now if I run this, it will print 10. See, it is printing 10. Okay, so why do we want to have constants in our program? Because variables are useful. We already know that. We can reuse them again and again. We can modify the values. We can do mathematical operations and then update the values. So variables are important. But why do we need constants in our programs? Because sometimes you may want to have certain values in the program that you do not want to change anywhere in the program. Suppose you are having something like this, const double pi. And whenever we are creating a constant, it is a naming convention. We always use capital letters for giving a name to the constants. So this is the value of pi. And you know, the value of pi is this. We cannot change it. So you do not want anyone who is working on your program to use a different value of pi. So if someone tries to update this value, you want to restrict them from doing that. That's why we have constants. You were explicitly telling the compiler that I do not want to change this value. So that's why we have constants in C++. Now let's talk about data types a little bit. You can think of data types as these little bags here. Okay, this data type tells you what type of data you can put into this bag and how much memory will be used to store a value into this bag. Suppose this is the smallest bag. It is the bag for storing characters. For character, we use this data type char. That is the short form of character. We call it char or char, whatever you want. We need 1 byte of memory to store a character. Okay, so this data type tells us we can only store character type of values into this bag. So if I store something like this, I store this. This is a P, an alphabet. If I store this, it is completely allowed. I can store an alphabet into this bag because this is the bag for storing a character. Now, if I want to store another character into this, suppose I want to store this V into this bag, what will happen? If I want to store this new value V into this bag, first I will have to replace P by v and then store it. So at a time, it can have only one value in the bag. That's the concept of a variable. You cannot have multiple values inside a variable. Now, what if I try to put a number into this bag? Suppose it's number 7 that I want to put into this bag. If I try to do that, first of all, I will have to replace the alphabet that I already had. It will be removed. And I'm using the same memory location. I'm not creating a new one. I'm just storing a new value into it. This 7 is stored in the character bag. So in C++, it will be written as char C equals to 7, right? And when you have 7 inside this variable called char C, do you think you are allowed to perform mathematical operations on this? Mathematical operations like multiplications, divisions, addition, subtraction, all those things. Actually, it will be allowed. We will see some examples and we will explain why that thing is allowed. But you will see in those operations will not be the same as the actual mathematical operations that you will perform on a number. So yes, you can do this. But here, this number 7 is not stored as a number. Rather, it is stored as a character. Okay, so this is represented as 7 as a text. Okay, now for integers, we have a bigger bag which is of 4 bytes. When you are creating a variable of integer type, you can store values which are numbers, whole numbers, into this bag. So I can store some value like 7 here, or I can store some other number, say 0. I can initialize a with 0. So if I just open this bag, I can put 0 here. That's how it is initialized. I have initialized a with 0 or stored some value 0 into it. If I do not put anything, that will just be an empty bag. And if I just put 0 into this bag, and if I try to print the value of a, it will give me the value 0. Data types in C++ help us define what kind of data a variable can hold. So when we are creating a variable in C++, the first thing that we mention is the data type. That tells the C++ compiler that I am going to store this kind of data into this variable. So when you write int a, that means you are going to store whole numbers into this variable a. It is not expected that you will try to store decimal numbers or characters or strings into that variable a. If you try to do that, it will not allow you to do that in most cases. And in some cases, it will behave differently. Suppose you create a variable like this, int a, and you try to store a equals to 10.5. Okay, you try to store this. Now, if you print the value of a, what do you think will be printed? You are trying to store the value that is accepted in a bigger bag. If you remember, the bag concept is double type. That bag requires 8 bytes of memory. You are trying to store that data into a smaller bag. So what happens when you try to put something bigger than the size of the bag? It doesn't go inside fully. Same thing happens here. If you try to store this 10.5, which is a double type value, into an integer type variable a, it will just truncate out the decimal part and 10 will be stored into a. So if I just run this, you will see the value of a is printed as 10 because it was not able to hold the part that was after the decimal point, since the data type of a was declared as integer. Now, if I try to store a character here, suppose I try to store this, what do you think will be printed? In this case, it will print 65. Let's see if we are getting that. Yes. Do you know why? Because 65 is the ASCII value of the character A. ASCII is ASCII, which is American Standard Code for Information Interchange. That is how every character is represented by a number in a machine, and that ASCII table is maintained across all the machines around the world. So the ASCII representation of alphabet A in uppercase is 65. So it is printing 65 here.